Lesson 9, Power. Section 9.1, Resistance. Let's assume that the voltage VR, given by this equation, is applied to the resistance R, and the current I flows. Then the power P of resistance R is given by P equals VRI. Let's substitute VR and I with the above equations. Using the trigonometric formula, P is separated into a DC component and a cosine 2 omega t component. This is the waveform of P. P is non-negative. The power is consumed by the resistor. The uppercase P denotes the average power of the instantaneous power P. The average power P is obtained as VRE, the unit of P is watt. By substituting VRE with RIE, P equals R times IE squared. By substituting IE with VRE over R, P equals VRE squared over R. Experiment 9.1. Construct this circuit. Set V equals Vm sin omega t, where the amplitude Vm equals 4 volts, and the frequency f equals 10 kHz. Measure the waveforms of the voltages VR, Vd, and the power P. Where P is defined as P equals VRI, and the current I is obtained by I equals Vd over Rd. Measure the effective value VRE, and the average value P bar. Normalize P bar by VRE squared, that is P bar over VRE squared, and it is equal to 1 over R. This normalization is for comparing the measured power with the nominal value. The results of experiment 9.1. These are the measured waveforms of the current I, the resistance voltage VR and the power P. The purple line is I. The orange line is VR, and the green line is P. The horizontal axis represents time and 12.5 microseconds per division. One cycle of I and VR took 100 microseconds. Thus, the frequency of I and VR was 10 kHz. The waveform of I is identical to that of Vd. The vertical axis of I was converted from 1 volt per division to 1 milliampere per division. The vertical axis of VR was 1 volt per division. The power P, which equals VR times I, was calculated using the math function of the oscilloscope. The vertical axis of P was 1 milliwatt per division. This is a snapshot of the oscilloscope. Pause the video and set the math function by following the steps indicated by the circled numbers. T0 and T1 are the inputs of channel 1 and channel 2, which are VR and Vd respectively. The product of VR and Vd will be calculated with this setting. This is a snapshot to set the measure function for measuring the effective value VRE, and the averaged power. Pause the video and follow the instructions. Step 7 is to click the vertical button of custom selection. Then, a pull-down menu appears. Click Stats in Cycle RMS, for measuring the effective value VRE. Cycle here means that the calculation uses data from one cycle around the triggering point. Then, the value of cycle RMS appears at the bottom of the oscilloscope. This value is statistical data. It represents the average of all measured data from the reset time to the present. It can eliminate noise. These are the mean settings for measuring the averaged power. Pause the video and follow the instructions. The mean value is averaged over the full range of the oscilloscope window. When f equals 10 kHz, set the time base at 12.5 microseconds per division. This way, the power P is averaged over 200 microseconds, which corresponds to 2 cycles of the voltage waveform. Be sure to reset the stats data before recording, to erase any data that might have been collected under different settings. This table shows the results of the experiment. The measured normalized power was 0.495, while the nominal normalized power was 0.5. The measured power closely matched the nominal value. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.